Welcome to a video on Pascal's triangle and the binomial expansion. You may have seen Pascal's triangle on a wall in your maths classroom, or even just if you've been to Questacon. It's an example of just a kind of pattern that is actually formed. So the start and end of each row is a 1, and the other numbers come from the sum of the two numbers that are directly above it. So our first row is 1, our second row is 1, 1, our third row, so you've got a 1 at the end, and the 2 comes from the sum of the two 1s that are above it. The next row, the 1's at the end, and then the 3's come from the sum of the two numbers above it. So 1 and 2 make 3, and 2 and 1 make 3. To get our next one, 1's at the end, 1 and 3 make 4, 3 and 3 make 6, 3 and 1 make 4, and you've got that 1 at the end. And then a final one to look at, what would be the next line if you were to write it out? And this is what you should have got: 1, 5, 10, 10, 5, 1. Hopefully you can recognize that it's symmetrical. Each row is symmetrical. And yeah, we'll look at those patterns as we go through. So the reason we use Pascal's triangle, or the reason it helps, is because it's actually supportive of the expansion of a binomial. Now, a binomial expansion is an expansion where the power is a binomial. And to introduce this concept for this video, we're only going to focus on 1 plus x to the n. So let's have a look. The first row is n equals 0, and it's 1 plus x to the 0. The next row is n equals 1, and that's 1 plus x to the 1. The third row is n equals 2, and that is 1 plus x all squared, and etc. down to the sixth row, where n equals 5. That's the expansion of 1 plus x to the 5. And those numbers actually relate to the coefficients for each of the terms. So we're going to have a look at each row and how it operates and how those numbers in Pascal's triangle are associated. So anything to the power of 0 is 1, and that's that first row. So when n equals 0, we just end up with 1. The next one, when you have something to the power of 1, you just get that. So 1 plus x to the 1 is just 1 plus x. So the coefficients are 1 plus 1x. So the 1 and 1 are part of your Pascal's triangle in that row, in the n equals 1 row. For n equals 2, this is a regular quadratic expansion, 1 plus x all squared. You can now see, using the way that we've learnt, when it's 1 plus x all squared, it's 1, 2, 1. So it follows Pascal's triangle. So 1 plus 2x plus 1x squared, or just x squared. So the power of 3, so when n equals 3, the coefficients are 1, 3, 3, 1. So your expansion is 1 plus 3x squared plus x cubed. See if you can do the next one, 1 plus x to the 4. So your coefficient should be 1, 4, 6, 4, 1. So you should get 1 plus 4x plus 6x squared plus 4x cubed plus x to the 4. What about 1 plus x to the 5? So once again, your coefficient should be 1, 5, 10, 10, 5, 1. So you get 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the 4 plus x to the 5. So those coefficients are very important, and we get them from our Pascal's triangle. So here's an example. we're going to use Pascal's triangle to write out 1 minus 3x to the power of 6. We're going to then do a couple of different expansions, 1 to a power of 3, 1 to a power of 5. And then we're going to discuss how we find the term independent of x. And then we're going to find the value of k from this expansion, given that the coefficients are in a ratio. So the first one, when we're doing to the power of 6, firstly, we've got to create the Pascal's triangle. So from the 1, 5, 10, 10, 5, 1, which was n equals 5, when n equals 6, we now add the coefficients from above. So 1 and 5 make 6, 5 and 10 make 15, 10 and 10 make 20, 10 and 5 make 15, 5 and 1 make 6, and of course you've got the 1 on either end. So what we're doing here is we are replacing what would be the 1 plus x to the 6. We're replacing the x with minus 3x, because that's the one that's filling in this case. So our coefficients, as you can see in the expansion of 1 minus 3x to the power of 6, you'll see the 1, the 6, the 15, the 20, the 15, the 6, and the 1 are all written first. Then you actually write the powers of your x, or in this case, minus 3x. So after the 6 is minus 3x, after the 15 is minus 3x squared, after the 20 is minus 3x cubed, after the 15 is minus 3x to the 4, after the 6 is minus 3x to the 5, and then you've got minus 3x to the 6 on the end. So expanding those, we end up with 1 minus 3x to the 6 is 1 minus 18x plus 135x squared minus 540x cubed plus 1215x to the 4 minus 1458 x to the 5 plus 729. For example 2, writing out the expansions of those two binomial expansions. So the first one is the power of 3, so its coefficients from Pascal's triangles are 1, 3, 3, 1. And it would be 3 lots of 2 to the x plus 3 lots of 2 to the x squared plus 2x cubed on the end, 1 lots of that, and of course the 1 at the front. And so when we expand that, we get 1 plus 6 over x plus 12 over x squared plus 8 over x cubed. 1 plus 4x to the 5. So the coefficients, or using the coefficients, using Pascal's triangles are 1, 5, 10, 10, 5, 1. And of course, we then replace the 4x in this case. So expanding that, you get 1 plus 20x plus 160x squared plus 640x cubed plus 1280x to the 4 plus 1024x to the 5. So therefore, in the expansion of those, that's then writing them as a multiple. And then we want to find the term independent of x. So independent of x means anywhere where we're going to end up with just a constant term, no x attached. So hopefully you can see some of the multiples. Like, we don't want to expand this whole set of brackets, but we just want to expand the ones that are going to just leave it with constant terms. So that's what we're going to focus on, just the independent of x, or the constant terms. So the red 1 times 1 gives us just 1. The yellow multiplication, 20x times 6 over x, the x's will cancel. The green 160x squared times 12 over x squared, the x squareds will cancel. And 640x cubed times 8x cubed, the blue one, the x cubes will cancel. So just focusing on those, okay, and we just want the coefficients because the x's cancel each other out and therefore independent. So you get 1 times 1 is 1, 20 times 6 is 120, 160 times 12 is 1920, and 640 times 8 is 5120. And the addition of those is 7,161. And that's the term independent of x. For our final one, finding the value of k for the expansion, given that the terms x cubed and x squared have coefficients 5:2. So we know that because it's to the power of 5, that's the n equals 5. So from Pascal's, it's 1, 5, 10, 10, 5, 1. And you can see that in our binomial expansion, our replacement of our x is 3kx. And you can see that written down, moving from 3kx to the 1, 3kx squared, all the way to 3kx to the 5. So expanding those, and you get 1 plus 15kx plus 90k squared x squared plus 270k cubed x cubed plus 405k 4x4 plus 243k 5x5. Now the question said the terms x cubed and x squared have coefficients in the ratio 5:2. So the x cubed term is 270k cubed over the x squared term is 90k squared, and that has to equal to the ratio 5:2, which can be written as a fraction, 5/2. Simplifying the left-hand side, 270 over 90 is 3, and k cubed over k squared is k. So that gets you 3k equals 5/2, and k equals 5/6. Thank you.